In this video, I'm going to go over some of the data file formats that you find at the microprobe imaging beamlines at SSRL. I'm going to start by showing you the files that are in the My Documents section. Each of the major programs has their own set of documents here and files. First, in the Data Queue program, you'll find the Data Serve file. And here is a directory information about where data will be directed to. And in each of these, you will have any queues that you may have saved. Every time you begin a queue, there's an auto-save function that will save the entire queue with the date and time. And the last item that is entered into the queue at any time is also in this last scan info queue. The file of these are a Python widget format that allows it to be easily read. It's not very readable in English, but it has all the information that you can see here. Now, the most important file in the data serve sections here are the data log. And this saves a mini notebook, in a way, of all the parts of the beamline that have been done during your experiment. So for every queue that is run, it will give you a line item, which queue item it was, what kind of scan was done, this is an image for instance, all the parameters that were passed to it, its start and end time, as well as the total time elapsed. And it will do this for every item and every queue that you run, and we'll save it as a running notebook. If you are running other queues then that do things like change the energy and realign, it'll save all that information as well. Let's see. So now, if we look inside the Microscan folder, here, again, you have data files that are saved for each session and the directory bit that tells you which one is active. Then we have three files that basically are the parameters for the three modes of operation: step scanning, continuous scanning, and bidirectional scanning. This is the file that you end up editing within Microscan to set the names of the channels or what have you in that case. The important bits here in particular are bits about how fast things should be driving, the XPS speed, how much offsets are given for doing the continuous scan modes, how far it'll go off the edge of the map before it will stop moving. And depending on the orientation of the beamline, you might need to use some of these reverse dirt flags to make sure the stage is going in the way that you believe it should be. Also key here is the low limit flags. This is the number of counts in the I0 ion chamber V to F that is required to trigger the low limit. It'll wait for it to get above that again. As a general rule, there are 100,000 counts per volt, so this would be about 0.05 volts. And the low limit wait is how many seconds it'll wait after it gets above that level before it begins scanning again. And this might be you might want to set a little bit higher in general, to maybe be a few minutes to make sure the beamline has equilibrated after the beam has been restored. Next, a lot of settings here versus where different pieces of hardware are. There's calibration for the timing factors involved in the estimation of how long a scan is. And then all the different devices and the channels. In particular here, we have all the names of the channels and which elements the different ROIs correspond to. And that is the basics of the Microscan files. All the other ones are very similar, but they just are loaded up with the various different experiments, whether it be stepwise, continuous, or bidirectional. The last major one is MicroXAF. This is divided into data, detectors, and regions. There's also a setup file here which has a list of all the motors in the beamline. So we're going to take a look at that real quick. There we go. Okay. And when you add motors in the XAS program, this is where it will show up here. And so you will have all the different motors that you're able to move at the beamline in this list here. It also will tell you which motors the queue are running. So if you are running queues, it'll run Y and Z in the queue. And you can change all of these. It's better to change these through the XAS program rather than trying to edit this file. Within the data file, of course, is all the data files that are stored in all your data sessions. Detectors has all the different detector formats that can be run at the beamline here. This format here is fairly straightforward. Again, another text file that can be easily read. And it has bits like what devices of the clock, again, the low limit issues here on what the low limit is for triggering it to pause and how long it will wait. The options here can be restart or continue. For XAS, it's best to restart that particular spectrum. The other important part here is the XSP point mode, and this will determine if you are using the Express 3 detector system, if it will treat this as a single capture or an entire spectra at a single session. Usually we don't want to have point mode on unless we are using a clock that is sensitive to the very small pulses that are sent out. And your beamline scientists can let you know which device, which beamlines are most likely to have that case. Then we have a list of the devices, so the ion chambers here, and the express system here. Normally, we only collect the first 4 ROIs, so if you want to do XAS, you should put those in the first 4. But if you talk to your beamline scientist, this can always be expanded to include more. Finally, in our regions, we have the different files that are used for defining what a spectroscopy region looks like. And here, for instance, we can look at the iron zanes, and it just tells you, again, what the name of the region is, element and edge, and the different regions and their spacing. So this is start and spacing and how many points, and then the overall timing, how many seconds are spent at each point. Again, these files here are best edited within the actual XAS program, but they are stored in the regions file here. If you're looking to copy regions between different sessions, you can always look in this folder to copy them back and forth. We also have this custom scans file here. And this is all the unique scans that are defined at the beamline for doing macros in XAS. It looks fairly legible, but again, these should not be edited directly in this file, but should be edited in the XAS program itself. But all that information is stored here. Finally, in the documents folder, you do have also the XMAP folder. And this is where we save the settings for the parameters for windowing of the detector here. And it's usually recommended that every user saves your files in your folder here, so you can always refer to what those particular windows were later on. Now, all of the data formats that are saved in the DataServe, Microscan, and XAS folders will always be copied onto your networked T drive. Here you can see all the different various sessions, and you determine where it goes. And you'll get these 3 folders, the data queue folders, XAS and XRF, that will have a copy of all the data files that are appropriate to the beamline. You will have FTP access to this folder, and this is the main repository for your data to collect when you go home. Finally, there's one more set here in the main data folder. So in the source folder in SSRL local, there is a settings folder. These are set by your beamline scientist typically, and it has a whole series of different files, including how the beamline is set up, the different labels and such, and where all the networked equipment is configured. Again, not recommended to change these unless your beamline scientist recommends that you modify one of these files for your particular case. The last thing I'm going to mention here then is when we look at our XRF files, you will generally find that you have 2 files for every file name. You're automatically appending a file that has your base name with an energy. That's the energy that the data file was collected at. and an index for 1, 2, 3, 4, or 5 to prevent overwriting. You will find that there is a HDF file and a DAT file. The DAT file is a plain text ASCII that you can read fairly easily and parse yourself. And the HDF5 is the binary data file that we typically use most often. There is an option where you can turn off saving the DAT files, and if you're looking at one of the macro scale beamlines where you have very large files, it's recommended that you turn the DAT file off. Ask your beamline scientist how to do that, because that will save several minutes in every scan. In the XAS portion, you will also find, let me find a different data folder. You will often find, here we go, again, 2 different file formats for every data file that is collected. A plain text ASCII file, again, that's very straightforward, as well as an XDI format. The XDI format is used as the X-ray data file interchange and is supported by both 6-pack, Athena, and Large. In this way, you can easily transfer your data files between your different analysis programs if you need to. And that is a rundown of what's at the beamline. And I will just finally finish up on saying that if you look at the main page for the Microanalysis Toolkit, SMAC, on samsxrays.com, you can see that many different data file formats are supported for reading. All the data file formats for saving your work will be in the SSRL Microscan HDF5 format, but all these other formats here are supported for reading. If you have other file formats that you would like to utilize with the Microanalysis Toolkit, don't be shy. Make sure you contact me at SSRL, and we can include those formats in the next future release. I hope you enjoyed this video.